Examples of Cartesian products, Introduction. So far we've laid the groundwork. We've talked about what sets are, those collections of distinct objects, and we've introduced the idea of the Cartesian product, which combines elements from two sets in a specific way. Now, on this slide, we're going to move from just defining the Cartesian product to really understanding how it works in practice. We're going to do that by looking at several examples. To make things as clear as possible, we'll begin with relatively simple sets that have a small, limited number of elements. These are called finite sets. By starting small, you can easily see how the process unfolds. We'll carefully build up the Cartesian product step by step so you can see exactly how each ordered pair is formed. And as we work through these examples, we'll reinforce how the Cartesian product is actually formed, not just what the definition is. This will set us up for tackling more complex scenarios later on. Understanding the process. So let's move on to slide 2. As we discussed in the previous slides, we're now focusing on the Cartesian product. This slide really clarifies what that product actually is. It states, remember, the Cartesian product of two sets, A and B, denoted as a cross B, is the set of all possible ordered pairs. Now, when I say a cross B, that's how mathematicians write it, A with a cross symbol, next to B. It's a special notation to represent this specific operation on sets. And what it results in is a set containing pairs of elements. But these aren't just any pairs, they are ordered pairs. The next point elaborates on this. The first element of each pair comes from set A, and the second element comes from set B. So, think of it like this. You're taking one item from set A and combining it with one item from set B to create a pair. The first position in the pair is always filled by something from A, and the second position is always filled by something from B. Finally, and this is crucial, it says, the order matters. X, Y is different from Y, X, unless X equals Y. This means that if you have a pair like X, Y, that is completely different from Y, X. They are not the same ordered pair. Only if X and Y happen to be the same value would those pairs be considered equal. We'll see this in action with the examples coming up, but it's important to grasp this concept of order right away. It's a key difference between the Cartesian product and other set operations. We'll be building on this understanding as we work through the examples, so make sure you're comfortable with these ideas before we move forward. So let's move on to slide 2. Example 1, simple sets. So now we're moving into the examples, and this is where things will really click. On this slide, we're going to start with a really simple example to illustrate how to find the Cartesian product. We're given two sets, and let's look at them closely. The first set, labeled A, contains the elements 1 and 2. I'll say that as A is equal to the set containing 1 and 2. The second set, labeled B, contains the elements A and B. So, B is equal to the set containing A and B. Now, remember from the previous slides, the Cartesian product, written as a cross B, gives us all the possible ordered pairs we can make by taking one element from set A and one element from set B. This slide tells us how to do that. To find a cross B, we need to create all possible ordered pairs. This means we take each element from set A and pair it up with every element in set B. We'll see exactly how that works in the following slides, step by step. So, we're essentially systematically combining elements from A and B to form these ordered pairs. Keep in mind that the order within each pair is important, as we discussed earlier. Example 1, steps. This slide shows step 1. We begin by selecting the first element from set $1. That element is 1. Now for step 2, we need to pair this one with every element in set B$. So, we create an ordered pair with 1 and A, which we write as 1, A. Remember, the order is important here. 1, A is different from A1. Then, we pair 1 with B, giving us the ordered pair 1B. So we're continuing to build our understanding of Cartesian products with these examples. Now, let's focus on slide 4. As you can see, we're starting to actually construct the Cartesian product, A times B$. Remember from the previous slides, $1 is the set containing the numbers 1 and 2, and B$ contains the letters A and B. So, these are the first two ordered pairs that will be part of our final Cartesian product. We've taken the first element from A and combined it with all the elements of B dollar. In the next slide, we'll repeat this process with the second element from set A dollar to complete the construction of A times B dollar. Example 1, Continued steps. So we've been working through examples of Cartesian products, and we're currently looking at sets A and B. Remember, the Cartesian product, written as a cross B, is all the possible ordered pairs we can make by taking one element from A and one element from B. Now, let's move on to step 3. We already took the first element from set A, which was 1, and paired it with everything in set B. Now, we're going to take the second element from set A. Looking at our definition of set A, the second element is 2. Step 4 asks us to pair this 2 with each element in set B, so we'll pair 2 with A, giving us the ordered pair 2. A. Remember, we write ordered pairs inside parentheses, with a comma separating the elements. And then we pair 2 with B, giving us the ordered pair 2, B. So, just like we did with the number 1, we've now created 2 more ordered pairs using the number 2. In the next step, we'll finish this process by taking the last element from set A and pairing it with everything in set B. Keep in mind that it's crucial to pair every element from A with every element from B to get the complete Cartesian product. Example 1 Result. So let's wrap up example 1. As we've been working through, we've been systematically creating ordered pairs by taking each element from set A and pairing it with each element from set B. Now this slide shows the final step, combining all those ordered pairs we generated. Remember, the Cartesian product, written as a cross B, represents the set of all these ordered pairs. So, looking at the slide, we have a cross B equals the set containing the following elements: 1A, 1B, 2A, and 2B. Let me break that down again. We started with 1 from set A and paired it with both A and B from set B, giving us 1A and 1B. Then, we moved to 2 from set A and paired it with A and B again, resulting in 2A and 2B. This collection of all those ordered pairs, 1A, 1B, 2A, and 2B, is the Cartesian product of A and B. In the next examples, we'll continue this process with different sets, including sets containing different types of elements, to really solidify your understanding. But the core idea remains the same. Systematically create all possible ordered pairs, and that's your Cartesian product. Example 2, Different types of elements. So let's move on to our next example. As you've seen in the previous slides, finding the Cartesian product is all about systematically creating ordered pairs. Now, we're going to slightly change things up to show you that the elements within our sets don't have to be numbers. This slide introduces 2 new sets, C dollar and D dollar. That's C and D. Set C dollar contains the colors red and blue, so we have red and blue as the elements within the curly braces. Then we have set D dollar, which contains a triangle and a square. So, triangle and square are the elements of set D dollar. Notice that we're mixing text, words representing colors, with symbols representing shapes. That's perfectly fine. The Cartesian product works with any type of element. Just like in our previous example with sets A and B dollar, to find the Cartesian product of C dollar and D dollar, written as C dollar cross D dollar, we'll follow the same process. Remember, we take each element from the first set, in this case C dollar, and pair it with every element from the second set, D dollar. We'll be building ordered pairs, and as we've stressed, the order within each pair is important. In the following slides, we'll walk through the steps of creating those ordered pairs, just like we did before, so you can see exactly how it works with these new sets. Don't worry, the underlying principle remains exactly the same. Example 2, Steps. Step 1 tells us to take the first element from set C, which is red. Step 2 instructs us to pair this element, red, with each element in set D. So, we start by combining red with the triangle, giving us the ordered pair red triangle. Remember, the order is important here, so red triangle is different from triangle red. Then, we combine red with the square, resulting in the ordered pair red square. So let's continue building our understanding of Cartesian products with example 2. As you recall from the previous slides, we're essentially creating all possible ordered pairs from two sets. Now, looking at this slide, we're working with sets C and D. Remember, C contains the elements red and blue, and D contains a triangle and a square. So just with the first element of set C, we've already created two ordered pairs. In the next step, we'll repeat this process with the second element of set C, which is blue, to build up the complete Cartesian product. Keep in mind that we need to pair blue with every element in D, just like we did with red. This systematic approach ensures we don't miss any possible combinations. Example 2, continued steps. So, step 3 tells us to now take the second element from set C. That second element is blue. Step 4 instructs us to pair this blue with each element in set D, just like we did with red. So, we'll create an ordered pair with blue as the first element and the triangle as the second element, giving us blue triangle. Remember, the order is important here. Blue triangle is different from triangle blue. Then, we pair blue with the square, resulting in the ordered pair blue square. Let's continue building our Cartesian product. As we've been doing, we're working with the sets C and D. Remember, C contains the elements red and blue, and D contains a triangle and a square. Now, we've already taken the first element from set C, which was red, and paired it with every element in set D. So, we've now created two more ordered pairs, blue triangle and blue square. In the next slide, we'll combine these with the pairs we made using red to get the complete Cartesian product of C and D. Keep in mind that we are systematically going through each element of C and pairing it with every element of D. This is the key to correctly forming the Cartesian product. Example 2, result. Let's wrap up example 2. As we've been working through, remember we started with two sets. C and D. Set C contain the colors red and blue, and set D contained a triangle and a square. Now, this slide shows the final result of finding the Cartesian product of C and D. Written as C cross D, this means we've systematically paired every element from set C with every element from set D. So looking at the result, we have the set containing the following ordered pairs: red triangle, red square, blue triangle, and blue square. Notice how each pair consists of one element from C followed by one element from D, and importantly, we didn't miss any combinations. We took red and paired it with both the triangle and the square. Then we took blue and did the same. This complete set of ordered pairs is the Cartesian product of C and D. It represents all the possible pairings between the elements of these two sets. In the next example, we'll continue to practice this process with sets containing numbers and letters, building on what we've learned so far. So, make sure you understand this example thoroughly before we move on, as the core concept remains the same, creating all possible ordered pairs. Example 3, sets with numbers and letters. So let's move on to our third example. As we've been doing, we're going to find the Cartesian product of two sets. This time, we'll be working with sets E and F. Now let's define these sets. Set E contains the numbers 5, 6, and 7, so we can write that as E equals the set containing 5, 6, and 7. And set F contains the letters X and Y, so F equals the set containing X and Y. Just to recap, remember that the Cartesian product will give us a set of ordered pairs. We'll take each element from set E and pair it with each element from set F. We'll do this systematically, step by step, just like we did in the previous examples. In the next few slides, we'll go through those steps and build up the Cartesian product, E cross F, so keep these two sets in mind as we proceed. Example 3, steps. Step 1 tells us to take the first element from set E. That element is 5. Step 2 instructs us to pair this element, the number 5, with each element in set F, so we'll create an ordered pair with 5 as the first element, and the first element of F, which is X, as the second element. This gives us the ordered pair, 5x. Then we repeat this process, keeping 5 as the first element but pairing it with the second element of f, which is y. This gives us the ordered pair, 5y. So let's continue building our understanding of Cartesian products with this example. As you've seen in the previous slides, the key is to systematically create ordered pairs. Remember, our set E is defined as containing the numbers 5, 6, and 7, and set F contains the letters x and y. So, we've now created the first two ordered pairs that will be part of our final Cartesian product. We're systematically working through each element of set E and pairing it with every element of set F in the next slide. We'll continue this process with the next element from set E, which is 6, and build up the complete Cartesian product. Remember, it's crucial to be methodical to avoid missing any pairs. Example 3, continued steps. So let's continue building our Cartesian product. As we've been doing, we're working with the sets E and F. Remember, E contains the numbers 5, 6, and 7, and F contains the letters x and y. Now, we've already paired every element of F with the number 5. On this slide, we move on to step 3. We're going to take the second element from set E, which is 6. Then in step 4, just like before, we pair this 6 with each element in set F. So, we create the ordered pair 6, x, and then we create the ordered pair 6, y. Remember, the order within these pairs is important. 6, x, is a different ordered pair than x, 6. We're systematically going through each element in E and combining it with every element in F to create all possible ordered pairs. We'll repeat this process one more time with the final element of set E, and then we'll have all the ordered pairs that make up the Cartesian product of E and F. Don't forget, the next step is crucial to ensure we haven't missed any combinations. Example 3, final steps. So, step 5 tells us to finally take the third element from set E, which is the number 7. And in step 6, just like we did before, we need to pair this 7 with each element in set F. That means we'll create an ordered pair with 7 and x, which we write as 7, x, and then we'll create another ordered pair with 7 and y, which we write as 7, y. Let's continue building our Cartesian product. As we've been doing, we're working with the sets E and F. Remember, E contains the numbers 5, 6, and 7, and F contains the letters x and y. Now, we've already paired up the number 5 with both x and y, and then we moved on to pairing the number 6 with both x and y. Remember, the order within these pairs is important. 7, x, is different from x, 7. We're systematically going through every possible combination, taking one element from E and one element from F. Once we've done this, we'll have all the ordered pairs that make up the Cartesian product of E and F, and we can write out the complete set, which we'll do on the next slide. So, keep these two new pairs in mind as we move forward. Example 3, result. So let's wrap up our final example. As you can see on the slide, we've now systematically paired every element from set E with every element from set F, just like we did in the previous examples. Now, to formally define the Cartesian product of E and F, denoted as E cross F, we simply list all of these ordered pairs within curly braces. So, E cross F is equal to the set containing the ordered pairs 5x, 5y, 6x, 6y, 7x, and 7y. Remember, each of these pairs represents a combination of one element from E and one element from F, and as we've emphasized, the order within each pair is crucial. 5x is distinctly different from x, 5. If you count them up, you'll notice we have 6 ordered pairs in total. This makes sense because set E has 3 elements, and set F has 2 elements. The product of 3 and 2 is 6, which confirms the general rule we discussed. The number of elements in the Cartesian product is always the product of the number of elements in each of the original sets. This concludes our examples of Cartesian products. On the next slide, we'll summarize the key takeaways from these examples and also highlight some common mistakes students often make when working with this concept. So, make sure you've understood these examples well before we move on. Key takeaways. Let's recap everything we've learned about Cartesian products with these key takeaways. First, remember that the Cartesian product of two sets, which we denote as a cross B, always results in a set of ordered pairs. Think of it as building pairs where the order is crucial. Now, how do we build these pairs? Well, the first element within each of those ordered pairs always comes from set A, so you pick an element from it to start your pair. And naturally, the second element of each ordered pair comes from set B. You're completing the pair by choosing an element from B. It's really important to remember that the order of the elements within the pair matters. This means that a pair consisting of A followed by B is completely different from a pair consisting of B followed by A, unless, of course, A and B happen to be the same element. Finally, let's talk about the size of the resulting set. If we know how many elements are in set A and how many elements are in set B, we can easily determine how many ordered pairs, and therefore how many elements, are in a cross B if we use the notation where the number of elements in set A is represented by M, and the number of elements in set B is represented by N. Then the number of elements in a cross B, which we write as the cardinality of a cross B, is simply M multiplied by N. So the size of the Cartesian product is the product of the sizes of the individual sets. We'll look at some common mistakes students make on the next slide, so make sure you've got a good grasp of these core concepts first. Common mistakes. Remember that when we form ordered pairs, the order absolutely matters. So, if we have A and B, the ordered pair of B, which we'd say as a comma B, is completely different from B, A, B, comma A. They are not the same unless A and B happen to be the same element. This is a key difference between ordered pairs and just regular sets. This is a very common error. When you're creating the Cartesian product, you need to be systematic. You must pair every single element from the first set with every single element from the second set. It's easy to get rushed and accidentally leave out a combination. Double-check your work to make sure you haven't missed any pairings. It's crucial to remember what the Cartesian product does. It's not the same as finding the union or the intersection of two sets. The union combines all unique elements from both sets into one. The intersection finds elements common to both sets. The Cartesian product, however, doesn't give you a set of elements. It gives you a set of ordered pairs. Each pair combines one element from each of the original sets. If you want to know how many elements are in the Cartesian product of two sets, A and B, you don't add the number of elements in A and B. Instead, you multiply them. If set A has M elements and set B has N elements, then the Cartesian product of times B, which we say as a cross B, will have M times N elements. So, the cardinality, that's the number of elements of a cross B, is equal to M multiplied by N. So now we're moving on to a really important slide: common mistakes students make when working with Cartesian products. Understanding these pitfalls will help you avoid losing marks in your assessments. Keep these common mistakes in mind as you practice, and you'll become much more confident with Cartesian products.